Pile group analysis for platform foundation at the Dan FG location in the North Sea, soil investigation for wind farm foundation in South Korea and Japan, and Swiss cheese operation to mitigate jackup rig punch through offshore in Malaysia. His expertise extends to lake penetration analysis of mobile offshore drilling units, geotechnical analysis of offshore pipelines, pile stick-up and drivability analysis, anchor holding capacity for floating production vessels, and quality control of offshore soil investigation. He has worked on projects across Thailand, Malaysia, Brunei, Indonesia, and North Sea. His onshore projects encompass geotechnical analysis for various ports in India, foundation design for a 40-span bridge across the Yamuna River, foundation design for 150 rail bridges on the dedicated freight corridor, and embankment design for power plants and intertidal zones. His major clients include Indian Railways, IOCL, NTPC, CIAL, TTD, and L&T Infrastructure Engineering Limited. Additionally, Dr. Manoj is a registered patent agent with the Indian Patent Office and has published extensively in international journals and conferences. Over to Dr. Manoj.
Okay, thank you. So let me share my screen or. Shalini?
Sir, share it as a screen. Share the screen.
You can see my screen?
Yes, sir. Yes, sir. Please go ahead.
Okay. Okay. So today I'll be speaking about some geotechnical aspects of waterfront structures, specifically about port and harbor structures. So this is the outline of my presentation. First, I will be speaking about the step-by-step procedure for planning site investigation. Then a typical port infrastructure, then the different types of berthing structures, then geotechnical analysis, that is a geotechnical analysis for a typical berthing structure, then geotechnical analysis for breakwater, and concluding remarks. So as you may be aware, for most of the major projects, we start with a desk study. The desk study involves collecting data available in public domain. For example, in this case, in the case of port, it may be like a tidal chart giving the tidal range, then geological data and climate data. And also, if there are any old soil investigations done at that site, we need to collect that data. Similarly, geophysical data also. Or if there are any constructions nearby, we need, if possible, we need to collect the soil data and geophysical data. Many times we can get a lot of data from published literature. So once we have done the desk studies, we can plan geophysical investigation. The geophysical investigation consists of bathymetric study and seismic survey. So in bathymetric study, we collect the water depth across the site, that is across the site planned for port development. And using this data, we can prepare a contour map of the site. So once we have the contour map of the seabed, the next step is to get the soil data and the rock data below the seabed. That is the raw soil profile and profile of the rock below the seabed. So that is done using seismic survey. So using seismic survey, we can get the soil profile, that is various stratification of the soil, and also the stratification of the rock below the seabed. So using the data like the studies, bathymetric data, and the seismic data, we can prepare what is called a ground model. So this is an example of a ground model. This gives this preparation of this ground model is very important for the planning of soil investigation and also for the estimation of dredge quantities and also any other issues we may face during dredging. For example, if there are rock outcrops within the dredge zone, then we need to give special attention to it. So all this information we can get from the ground model. So now once we have the ground model, then the next step is we need to get the layout of the locations of various structures and the types of structures to be designed, the local Metotian conditions, that means the wave data, the predominant wave direction, the current data, and climate data. Also, details of existing structures. Existing structures means there can be buried pipelines or buried cables. So we need to get these details. Then the regulatory requirements means the permit system, that is, before doing the soil investigation, we need to get permit from local authorities. These requirements are different for different countries, and within the country also, it may vary. For example, in border areas, we may have to get a permit from different agencies. Then we already have a ground model, which gives the bathymetric data. And also from the ground model, we can get the seafloor slope and unevenness. Because the last part, the seafloor slope and unevenness is important for the deployment of soil investigation rigs. This shows a typical layout of a port. I have given only a minimum details. And this is the berthing structure. These two are the berthing structures. And these berthing structures provide a platform for loading and unloading of cargo and docking of the ship. The thick red lines shown here, these are breakwaters. The purpose of breakwater is to protect the harbor from waves, current, and storm surge. Now we have the data such as ground model and the layout of the different structures. With this information, we can plan soil investigation. The main components of planning are the number of boreholes required, the spatial distribution of the boreholes, and the depth of boreholes. First, when it comes to number of boreholes, one of the main factors which decide the number of boreholes is the soil variability. That is especially the strata variability, strata thickness variability. So, for example, the breakwater, the total length of breakwater may be about 3 kilometers. It varies normally in the range of 2 to 3 kilometers. So, we need to decide whether I can assign boreholes at every 50 meter, 100 meter, 200 meter, or 500 meter. It depends on the variability of the soil. If the variability is more, then we need more numbers of soil boreholes. Similarly, for the other structures like berthing structures, and also we need to assign boreholes in the dredge area because the enclosed area is to be dredged. This boreholes for the dredge area is required for the design of dredging, dredgeability analysis and all. So, one more thing I've got is so we have the number of boreholes and the spatial distribution, and the next important aspect is the depth of borehole. So we need to get the soil data within the influence zone of the foundation. For example, it can be the base 1.5 or 2 times the base width of the breakwater, or in the case of piles, we need data up to 10 meter below the anticipated the founding depth of the pile. So now we have the number of boreholes, the spatial distribution of the boreholes, and the depth of boreholes. Now the next step is we need to prepare a soil investigation specification. This is mainly for the tendering purpose and the quality control during soil investigation. So the specification should contain the number of boreholes, the spatial distribution of the boreholes, that is location of the boreholes, coordinate of the boreholes, and depth of boreholes, the frequency of soil sampling. That means whether we need a continuous sampling or the sampling at different depth intervals needs to be specified. Similarly, field testing. Very often we do SPT or CPT test. So sometimes within the same borehole itself, we do CPT as well as sampling. So in that case, the frequency is to be specified. Then the tolerances. For example, from the specified location, what is the limit to which it can be moved? Because there will always be a difference between the specified location and the actual location. So what is the limit to which this can move? This can change. Also, the accuracy of the depth measurements. It can be as low as 0.1 meter or 0.5 meter, or it varies for different projects. Then the specification of equipment to be used, and also the sampling tools to be used needs to be specified. What sampling tools to be used for soft clay, for the stiff clay, what sampling tools to be used for sand needs to be clearly specified. Then the list of laboratory tests to be carried out. What are the tests to be carried out for different types of soil like clay, sand, or silt? What are the tests to be carried out? It should be clearly given. Then sample handling and transportation. This is also very important. We need to clearly specify what are the precautions to be taken during handling of the sample and transportation of the sample from the site to the lab, so that the disturbance is kept to the minimum. In some cases, we specify the temperature also. The sample should be kept in certain temperature ranges. That is also specified in some projects. Then the report requirement, what are the deliverables in the report? So this shows a typical jack-up barge used for nearshore soil investigation. These barges are floated to the location. Once it is positioned over the borehole location, the legs, there are 4 legs, you can see there are 4 legs. These legs are lowered to the seabed. So once it reaches the seabed, the barge is slowly jacked up. So once the barge begins to rise above water, the load is transferred to the leg, and the legs start penetrating into the seabed. So if it is very soft clay, the penetration can be very deep. So we need to get some estimate of the likely penetration before mobilizing, because if in case of deep penetration, the available length may not be sufficient. So this needs to be taken care of. Now, this shows a case study of showing what can go wrong if the soil investigation is not planned properly. This is this is from a port location. It was originally planned as a gravity structure that is resting on seabed. It's a shallow foundation. So based on that assumption, they did the soil investigation. About 20 boreholes were done. And once they submitted the report to the consultant, then he realized that up to about 80 meters is very, very loose sand. So it rules out shallow foundations. So we need to go for pile foundation. But there is a problem. For designing pile foundation, the depth of boreholes were not sufficient. So then they had to go for another round of soil investigation. This is one of the problems which can go wrong if it's not planned properly. And also one more thing is during soil investigation, there should be a real-time communication between the engineer supervising the soil investigation and the consultant, so that we can decide the termination of the root. This is very often done in offshore. This is another case study. This data was taken after a failure. A part of the structure collapsed during a cyclone. So then further soil investigation revealed that there is a very soft clay, there are very soft clay pockets within limestone. So, but this was not revealed during the original soil investigation. And so this shows the importance of doing a seismic, that is high resolution seismic survey, and preparing a good ground model before planning soil investigation. So now we have the soil investigation done and the soil report is ready. So we have all the soil data for the design of the structures. Next step is to get the design basis. We need the design basis to start the design. The design basis should contain the as a minimum design standards to be used, and maximum design water level, and various design water levels like minimum design water level, mean high water springs, mean low water neap, and mean low water springs, mean low water neap, mean sea level, design dredge level. Very often we use a tolerance for the dredging tolerance. That is around 0.3 to 0.5 meter dredging tolerance to be considered while doing design and analysis. Also, properties of the materials to be used for breakwater. For example, tetrapod, its unit weight, and other properties are required for doing the analysis. Also, surcharge load on the soil behind the berthing structure. The surcharge load can be a road, a service road, or it can be a stack yard, like container yard. Then we need to get the factor of safety to be considered. That is, for example, in the factor of safety, maybe 1.3 for the static case for the slip circ analysis, 1.1 for the seismic case. So we need to get what is the factor of safety to be considered. Also, seismic factors for the location. Then the surcharge on the breakwater. If there is a service road on the breakwater, we need to get the what surcharge to be used. Now we have we can start the geotechnical analysis. The first step is what is called option engineering, in which we consider different alternatives. This is a group activity involving geotechnical engineers, structural engineers, and planning engineers. So, for example, the berthing structure can be a gravity structure resting on the seabed, or it can be a piled structure with a diaphragm wall. Just two examples I showed. There can be many. So, for example, if you have decided to use pile structure, there are different options possible. For example, this is a diaphragm wall which retains the soil, and the piles are there to support the deck. So the diaphragm wall can be on the front side, or it can be on the back side also. There are advantages and disadvantages. So we need to do analysis and see which one is more economical. And even we can provide an anchor wall at the backside. So this also we need to do the analysis and see what is the effect of providing anchor wall, whether we can reduce the pile diameter or the thickness of the diaphragm wall if we provide anchor wall. That needs to be analyzed. And even anchor wall itself can be a diaphragm wall or it can be batter piles. So all these we can do, we have to do all these alternative analysis for the alternatives. And once it is decided finally based on the technical feasibility and the cost, then we can start the detailed geotechnical analysis. During this option engineering, the geotechnical analysis required is preliminary analysis. So now once we have decided a structure, assume we have decided a pile structure with a diaphragm wall, then we need to give the various the forces acting on the diaphragm wall. For example, earth pressure acting on the diaphragm wall. Then if there are surcharges, the pressure due to lateral pressure due to surcharge acting on the diaphragm wall. There can be different surcharges at different depth, different distances. Then there is something called differential water pressure. The differential water pressure is because due to when there is a tidal variation, the sea level varies, and when the sea level varies, the groundwater level also changes accordingly. So that means, but because of the permeability of the soil, there will be time lag between the variation of the sea level and the groundwater level. So that means we will have a different water levels on both sides of the diaphragm. So this will create a water pressure on the diaphragm wall. This needs to be considered. And then we need to consider the soil resistance. The soil resistance is very often considered as springs. It can be linear spring or it can be non-linear spring. And if we need the anchor wall, then we need to consider the forces, that is your pressure acting on the diaphragm wall, surcharge acting on the diaphragm wall needs to be considered. And also the soil resistance is modeled as springs acting on the diaphragm wall, acting on the springs, and acting on the anchor wall. So now we have the structure with all the earth loads and surcharge loads, water pressure loads, and also environmental loads and operational loads. And resistance is modeled using soil spring. So this is a typical soil structure interaction problem. So once this is modeled in a structural engineering program, software, we can get the deflection, the bending moment, and shear force for design of the various structural components like piles, diaphragm wall, and the deck. Now, once the founding level of diaphragm wall and the anchor wall is finalized, we need to do a global stability check. So this is in this particular analysis, we have neglected the contribution from piles. So this factor safety, normally it varies in the required factor safety varies from 1.3 to 1.5 in the normal conditions. Similarly, same analysis we have to do for seismic condition also, and the factor safety is different. Next is breakwater. This picture shows the breakwater being constructed. This shows a typical cross-section of a breakwater. So this we have a tetrapod to dissipate the wave energy, and the core is made of a core iron, and there is another secondary layer, the rock layer. It's basically heavy rock, 500 kg rock. Then there is a filter layer to prevent the toe erosion. So the analysis are, we need to do a slip circle analysis to check whether the slope provided is safe or not. If it is the factor of safety is not sufficient in both, then we have to change the slope or provide a berm. So then next is the settlement analysis. So this is done in Plaxis 3D, a three-dimensional analysis done. So this gives the settlement of the soil below the breakwater. But this is only a theoretical settlement. When you place during the placement of the breakwater itself, if the soil is very loose or very soft clay, it will displace the soil. In very soft clay, it can be up to 3 meters. So this needs to be considered when estimating the quantity required for the breakwater. Next is the liquefaction analysis. That is, if the seabed soil is very loose sand, then it is likely to liquefy during a seismic event. Liquefaction is when the loose sand is saturated loose sand or submerged loose sand is submerged to seismic induced vibrations. It will momentarily behave like a thick fluid. So this is known as liquefaction. And mitigation measures are to combat the soil. So there are different techniques available for underwater compaction. So if once it is compacted, for example, if it is loose sand is converted to medium dense sand, we can prevent the likelihood of liquefaction. So these concluding remarks I have presented a step-by-step procedure for the planning of soil investigation. So case studies were presented illustrating what can go wrong if the planning is not done properly. Also option engineering and what are the process of option engineering, and outline of the process of option engineering is presented. Also very outline of the geotechnical analysis of berthing structures also presented. Thank you. So any questions?
Thank you, sir. Participants?
I have not presented the details of geotechnical analysis because I understand most of the engineers are transportation engineers. So I kept this in mind while preparing the presentation.
So you mentioned the liquefaction analysis and underwater compaction can be done. Can you elaborate on that? What are some of the methods for underwater compaction?
One of the most common method is vibrofloat. So it can be, it's like a pipe vibrating. You lower the pipe into the soil and it rotates at a certain angle, and we feed the sand into the pipe. Thereby it compacts. This is called vibrofloat.
For the bridges also, we do similar analysis, right? All the stability.
Bridges, there are bridges we do. First thing is, most important thing is cover analysis, because the design, we need to get designs cover. For some rivers in India, it can be up to 20 meters cover. So we need to get this cover correctly. So then all the designs depends on this curve, geotechnical design. And also stability, especially the abutment. All this earth pressure will be acting on the abutment, which ultimately come to the foundation. That's why I think one option is to provide a mixed abutment. I think that mixed abutment means using reinforced earth wall. So that means reinforced earth wall will take care of all the lateral load internally. This is done in, I think, Alva, Marthandorma Bridge.
Thank you, sir.
Sir, in that breakwater construction method,
Yeah.
the initial is the quarry and material you have mentioned. So what is
Yeah.
the quarry and material? It will be like a dredged material or it will be done?
Quarry run consists of rock, like up to there's a 500 kg rock, and also like the what we call M sand, P sand, all this. It's a combination of all.
Is it possible to use the dredged material from the sea or?
No, we don't use it. Normally don't use dredged material for seabed from this construction, but dredged material are used for reclamation. Very often we need to reclaim the land behind the berthing structures. So this one of the studies we do is we check the soil characteristics and identify what is the quantity of the dredge material available for the reclamation. This is one of the studies we do, because sometimes they have stringent specification. For example, the dredge material, that is the materials to be used for reclamation, should have the percentage passing 75 micron, less than 10% or 12%. So this criteria we need to check, and also clay content should be less. So this we need to check whether what is the quantity available which satisfies this criteria. So based on all the bore log data, we can estimate what is the quantity available which satisfies this criteria.
Sir, I have a question. You said that in option engineering, various types of structures are considered and alternate analysis is done for each structure, and
Yeah.
only preliminary geotechnical analysis is done. So what is the criteria for fixing which type of structure is to be used? Is it structural analysis or?
No. Basically, it's a structural analysis. Ultimately, what they do is they suppose we are doing 5 options. Then they make a table. What is the quantity? What is the quantity of cement? What is the quantity of cement in each option? Quantity of the steel required in each option. Then, like that, all the quantities are analyzed, and the cost analysis done. So very often the one which gives the least cost will be considered. There are other factors also considered. For example, construction the difficulties. Certain options, for example, diaphragm wall. If you decide the diaphragm wall is the best option, if it is very loose sand at the top, construction of diaphragm wall is difficult. So we may have to go for sheet pile wall, which may be costlier. Driven sheet pile wall. So these are we cannot give a clear hard and fast rule. We mainly the constructability and the cost. These are the 2 factors to be considered.
Okay, thank you, sir.
So some cases, you said that in different options, gravity structures are also preferred. Are there the gabion walls or?
No. These are concrete blocks. They make big concrete blocks and play it like stacking of concrete blocks, interlocking blocks.
With same or the stability analysis and everything.
Yeah, we need to do stability analysis for each and every block.
So for the berthing structures, most of the time we provide pile foundation only, or do we provide any other special foundations?
Very often it is pile foundation because very often we find very soft clay or very loose sand. For example, in Cochin area, it's very soft clay. And the shallow foundations like a gravity wall is suitable if they have a rock layer at the very shallow depth. Sometimes we get a limestone or the weathered rock at shallow depth. So in that case, we can go for the gravity wall, because otherwise the bearing capacity required is very high for the gravity wall. You won't get that bearing capacity in clays and sand and loose sand or medium dense. We don't get the required bearing capacity. That's why very often we go for pile foundations.
Sir, we have a question in the chat box. It was a very interesting presentation. Thank you, sir. What are the different conditions in which soil structure interaction needs to be considered? What about the inclusion of pile group effect?
Pile group effect, yeah, okay. This here, when we are providing the springs, that is especially we are providing non-linear springs, what is known as PY springs, we check what is the distance between the piles. So if it is 5 times D, then we don't have to worry about the interaction between the piles. So if it is less, the P value, that is P it is known as P and Y, the P value will reduce to consider the interaction effect. That is how we consider interaction between the pile. So how to reduce the soil resistance because of the interaction. That's the goal. Because when we give a springs, if the interaction, if there is an interaction, the spring value will reduce. How much is to be reduced? We need to decide. But very often we keep it like 5 times or 6 times, because generally it's around 6 meters center to center, these piles. And diameters ranges from 1.2 to 1.4, the pile diameters. So interactions is not really an issue in this case, if you provide the sufficient space in between the piles.
Good morning, sir. This is Wilson. I have two doubts.
Okay.
First one is actually in the case of breakwater, is there any requirement to collect boreholes in cross-sectional directions?
Cross-section means across the length, is it?
Yeah, yes, sir.
Normally what we do is we don't take along the center line, we don't take, we in a zigzag position. So that it, understood?
Yeah, yes, sir.
One borehole maybe on the port side, maybe next borehole maybe on the sea side. So it goes like a zigzag. It's not like along the center line.
Okay. The second question, sir. Actually, in the case of seawall construction, is what are the factors to be considered, sir? In the seawall, not seawall, sea bridge construction.
Sea bridge construction, there is called here also we use what is known as approach dressing. That is, it's like a bridge connecting land to the berthing structure. So first thing to be considered is the in this case, the port case, is the dredge slope. So I not explain much about the dredge slope. We need to decide what is the dredge slope. It's a different from the slip circle or analysis. The dredge slope is once the area is dredged, for example, dredged to minus 16 meters, it will form the dredge itself. During dredge itself, it will form a slope. Normally, based on the soil, it can be 1 in 2, 1 vertical, 2 horizontal, or 1 in 3. But in the long term, due to the movement of ship or the currents, a long-term slope will form. Normally, if it is, we consider a 1 in 5, very good soil, if 1 in 4, that is 1 vertical to 4 horizontal. If it is very soft clay, very loose sand, it can be up to 1 in 10 also. That means 1 vertical to 10 horizontal. So this is one of the most important factor in the analysis for the approach trestle or even port structures. We need to decide. There's a British code which gives some rough guideline. What is the slope to be considered? That is dredge slope to be considered for different types of soil. So here, very often we use either 1 in 4 or 1 in 5, unless it is very soft.
Yes, sir. Thank you, sir.
Regarding soil structure interaction, we have one question. What are the different models considered in the modeling? SSI in a practical scenario, is it Winkler model? Winkler?
Basically, basis is Winkler hypothesis is the basis. When we use pile to generate the PY, that is non-linear springs. There are different ways of different procedures to develop the non-linear spring, like APA method, Rees method, different method. But the basis of all this Winkler hypothesis. There is another procedure which is also very commonly used, especially in India. There is a linear springs. So this is, I think in Powell's book, they are given the procedure for estimation of linear spring. The problem with using linear spring is, suppose you use a linear spring, then we need to estimate when during structure analysis, we need to find out what is the load acting at that spring. And if the load is exceeding the spring value, we need to replace it with a passive resistance. It's a very tedious process.
Thank you, sir.
Sir, one more question. We are actually handling some waterway project. In that case, 20-meter interval deep vertical cuts are considered. In such cases, what are the soil considerations to be taken care of?
See, if you see this, my presentation, the main focus is all based on my experience, is to do a proper geophysical survey first. Then, so that will give a clear idea about the soil stratification. Then decide where you need to have the bore log, what is the depth of boreholes. In case if it is not done, then 20 meters should be sufficient. If it is a major project, then definitely a geophysical survey needs to be carried out first. Otherwise, 20 meters should be okay. And what is this soil investigation is for what purpose? Is for dredging or for design of retaining structures?
Yeah.
Sir, it is for the design of retaining structures, and what she was mentioning is the depth was 20, coming around 20 meters.
Depth
So,
of what? Depth of bore log?
no, sir, the depth of the cut.
Oh, depth of the cut is 20 meters. Then we need a very deep foundation, very deep bore log.
It is a cut section, so it's coming around 20.
So you were telling depth of the cut is 20 meters. What is the depth of bore log you're asking? Is that the question?
Type of retaining. So the type of retaining structures which is more suitable because it is a waterway.
It depends on the soil data there. If it is a very soft clay, if it is soil is like, for example, lateritic soil, then a gabion wall can be used. If it is a very soft clay, then we may have to go for some pile foundations, pile structures, contiguous pile or the soldier piles. Those options needs to be considered. It all depends on the soil data there. Because 20 meters is not a small thing.
Okay, sir. Thank you.
Any other would like to ask questions?
Sir, in case of artificial harbor, so what are the aspects we have to concern more as far as compared to the natural harbor. So in case of the planning or in case of the geotechnical investigation.
The whole thing I explained is about the artificial harbor. It's not for natural harbor. Because for the artificial harbor only, we need to do all these studies. Especially the dredging. Artificial harbor, the main issue will be dredging. We may have to dredge up to, say, from the ground level up to, say, 20 meter or 50 meter, 20 meter. We may have to dredge depending upon the port we are designing. So this is one of the most important factors to be considered, the dredging. And its environmental impact needs to be considered during planning compared to a natural harbor.
Okay.
Any other question? If not, we'll wind up.
Thank you. Now I would like to invite Shri Jagan Bharat Kumar, a scientist, Highway Engineering Division, NATPAC, to deliver the vote of thanks.
Good morning, all. It is with a great honor that I come before you today to thank everyone who has played a part in making this lecture a reality. Shri Wilson, Senior Scientist and Scientist in charge of Highway Engineering Division, Shri Subin, Senior Scientist, and our Director, Dr. Samson Matthew, and all of my fellow scientists and project fellows, my deepest thanks to all. My most sincere thanks goes out of each and every one of the esteemed participants who graced us with your virtual presence. I hope everyone has found this intricate subject to be interesting and useful. The incredible presentation on geotechnical aspects of planning and design of port and harbor structure delivered by Dr. Manoj Mukundan, and I am very grateful to him for taking the time out of his busy schedule to teach us. Dr. Manoj have spoken on site investigation for planning and design. With respect to planning site investigation, which include disk studies, geophysical survey details, and also he elaborated on the soil investigator specification, improper planning of soil investigation with the help of the case studies, and on the design basis that we have to consider while planning and design of the port and the harbor structure. And he also elaborated on the option engineering, geotechnical design of berthing structure, global stability check, breakwater, slope stability, settlement analysis, and liquefaction analysis. Sir, we thank you once again for your valuable time, and thank you so much.
Okay, thank you.
Thank you, sir. We'll wind up.
Okay, thank you.
Yes, sir.